Next in our conversation about number systems, we're going to talk about bytes, nibbles, and all that jazz. First, we'll talk about bits. We've seen these in our binary numbers, and there's two bits in particular that we want to pay attention to. The most significant bit, this is the bit in our binary number that represents the largest power of 2, and the least significant bit is the bit which represents the uh, smallest power of 2. Bytes and nibbles. Bytes are 8 bits and a way of grouping binary numbers. Again, so when we represent these as hexadecimal numbers, each byte is going to be represented by 2 hexadecimal numbers, since each hexadecimal number represents 4 bits. And a nibble is just a less common term, but is one that is used to represent 4 bits, which conveniently then can be represented as a single hexadecimal digit. Similar to the way we talked about most significant bits and least significant bits, bytes also have a designation in terms of the most significant byte. This would be the byte that represents the most significant part of the value, and the least significant byte is going to represent the smallest chunk of the value that we're talking about. It's also helpful to have a general sense of powers of 2 and what their values are in the decimal base 10. So if we look at these, 2 to the 10th power is equal to 1 kilo, 2 to the 20 is 1 mega, 2 to the 30 is 1 giga, and so on and so forth. And you can see on the left-hand side the values of the powers of 2, and on the right-hand side the powers of 10 that those are approximately equal to. So in 2 to the 10, 1 kilo is 10 to the third, 2 to the 20, 1 mega is approximately 10 to the 6th, 2 to the 30, 1 giga, approximately 10 to the 9th. And so this will be helpful as you're talking about the size of binary numbers, and you'll notice that these are commonly used. You've probably seen these when you're looking at file sizes on your computer, that a certain file is a certain number of megabytes or gigabytes, or also when you're doing a speed test on your internet connection to see how many bits, how fast your connection is in megabits per second, hopefully no longer in kilobits per second. And this gives you kind of a way to estimate approximately how big those numbers are in terms of their decimal equivalents. So if we just want to kind of get a little bit of practice with this, again, those values are worth committing to memory. You'll use them quite a lot, and they'll come in handy. And you don't want to always have to look up that table. So if we see the value of this, 2 to the 24, you might say, well, how on earth am I going to estimate what that value is? But if you know those ones from the previous slide, it's actually not too bad. So here, first what we can do is we can take 2 to the 24 and we can split this into pieces that we recognize. So first we can say 2 to the 24 is equivalent to 2 to the 4th power times 2 to the 20th power. We know 2 to the 4th is equal to 16. And we know from the previous slide that 2 to the 20 is approximately equal to, so we should change this value to approximately, 10 to the 6th. And so this is going to be approximately equal to 16 times 10 to the 6th, or 16 million. Similarly, if we wanted to know how large of a value we can represent with a 32-bit integer, we're going to do the same thing. So we know a 32-bit integer number can represent a value as big as 2 to the 32nd power. Using a similar strategy as what we did above, we can split this into 2 squared times 2 to the 30th power, which is approximately equal to 2 squared is 4 times 2 to the 30, we know from our previous slide, is approximately 10 to the 9. And so this is going to be approximately 4 billion. So again, knowing these values allows you to very quickly estimate and get a sense of how big a certain number is. And this is always really useful as a rule of thumb when you're trying to figure things out.